All right, so now we're getting into other facets of functions. And we talked a little bit about this in earlier videos, but we're going to dig more deeply into it now. So we're going to be talking about domain and range. So remember, domain is the set of all values or inputs of the independent variable for which the function is defined. This is also sometimes called the implied domain. If x is in the domain of f, then f is defined at x. If x is not in the domain of f, then f is undefined at x. So that's really your starting point when you're looking at a function is what values can I plug in? So that's, again, what inputs do you have available? And so you want to know what you can plug in and what you can't plug in. The range, on the other hand, is what do you get out of it? So that's all of your outputs, and they are based on the dependent variable that is the set of all function values. So we can look at domain and range from a couple of perspectives. Now, just for reference, because I had errors in my notes, this number 3 I circled in red, and I'm going to call it number 4 for the video, and I'm going to change a couple more numbers as we go on. So if we want to look at the domain and range of each relation, now it could be a function, it might not be a function though, but a relation doesn't distinguish or determine or count against you in either case. So, all right, so let's look at our domain. Let's just abbreviate with a D. And because it's a set of numbers, in this case, let's use our curly braces. And so what inputs do we have for this relation? And so all you really care about is what's the first number in each ordered pair. So we have a -3, we have pi, we have another -3, so we don't need to repeat it. And then we have a 5. So we want all the unique values of x in our ordered pairs. So there's just 3 of them. Now for our range, now we're looking at our outputs. So we got a positive 1, we got a square root of 2, we have a 6, and another 6. So we just have 3 unique values of y or outputs. So there's our domain and range. Nothing fancy there. What about when we have an equation? Still doing the same thing. So we want to just ask yourself, what values of x are you able to plug in? Now they gave us values of x here, but here they want you to think about what values of x can you plug in? Are there any problem values of x that would give you a wonky y value? And in this case, there is no bad values of x. I can plug in any value of x I want, and I'm going to get a y value out of it. So in this case, the domain is all real numbers. Now you can say it in words, but a more compact way is to use interval notation. Now if you're a little rusty on interval notation, it's kind of like an ordered pair in a lot of cases, but sometimes it might have square brackets and sometimes it might have parentheses. Now because it's all real numbers, we want to use parentheses. So we would say parentheses, and we want to go from negative infinity to positive infinity. And again, parentheses. When we're stopping someplace in there, we might want to use brackets, we might not. So, and I'll explain that when we see it. All right, so there's our values of x. Everything works. But what about our values of y? Do we have all values of y that can be attained in this equation? Now that absolute value should be setting off some red flags and alarms and bells and whistles. So because that's never going to be negative. No matter what value of x you plug in there, you're always going to get a positive number. So the question is what's the smallest positive number that you could possibly get from that equation? Well, I mean, you can test a couple of numbers if you want, but hopefully you can kind of see that 0 is going to be the smallest number that you could possibly get out of that. So, but because you're adding 5 to it, 5 is actually going to be the smallest output you could possibly get. And then anything else bigger than that will be in there as well. So how do we write that in interval notation? Because we want to include 5 in those outputs, we're going to want to use a square bracket. And so we're going to start at 5, but then we want to go all the way to infinity. And again, we use our parenthesis on the other side. So this includes 5. If we wanted to exclude it, then we would use a parenthesis. So be careful. Parentheses matter, brackets matter. All right, so let's take a look at this last one. Y equals the square root of 2x minus 1. All right, so square roots, again, negatives, we're going to want to be careful around negatives and stuff. But the question is let's start with the domain. What values of x can we plug in and get a value of y out of it? So could we plug in 0? 0 is always a good place to start, even if it doesn't work, because then you can kind of go off from there. So can we plug 0 in? No. 0 is going to give you a negative 1 underneath the square root. You can't have a negative under a square root. So 0 is no good. So could we put some negative numbers in there? Well, a negative times a positive is a negative, and then we have more negative. No, more negatives are not going to work. So we got to look at some positive numbers. So what's the smallest positive number we could use and get an answer out of it, get an output? Now, if you're not sure and you wanted a mathematical way to do it, easiest way is to set it equal to 0. Whatever you have underneath that square root, set it equal to 0. And that's going to help you get to that smallest value. So x, we can see, should be equal to 1/2. So 1/2 is going to be the smallest positive number. As soon as you go smaller than that, it's not going to work. If I took negative 1/4, negative 1/4 times 2 would be 1/2. 1/2 minus 1 is negative. So 1/2 is the smallest one because it gives you 0, and the square root of 0 exists. Square root of 0 is 0. So what should be our interval? We know that smallest value is 1/2, and it's included. And we can keep going up from there. So the domain should be that. Now, what about the range? So what values of y can we get out of it? We know we can get 0, but can we get anything below that? Can you get a negative answer from square rooting something? Not unless you have a negative in front, which we don't. Excuse me. So 0 looks like it's going to be the smallest, and can we get any positive number above that? Yeah, we can find a way to get to it. So in this case, 0 is included, and we want to go all the way to infinity on that one. So there's some problems on domain and range that hopefully will kind of get you head in that direction. We're going to see some more applications in the next video though, so stay tuned.